Let's now take a look at the second important fundamental design goal of the Internet, interconnection, and how interconnection is achieved with a design principle called the narrow waist. Let's keep in mind that one of the main goals was to interconnect many existing networks and to hide the underlying technology of interconnection from applications. This design goal was achieved using a principle called the narrow waist. The Internet architecture has many protocols that are layered on top of one another. At the center is an interconnection protocol called IP, or the Internet Protocol. Now, every Internet device must speak IP, or have an IP stack. Given that a device implements the IP stack, it can connect to the Internet. This layer of the network is sometimes called the network layer. Now, this layer provides guarantees to the layers above. On top of the network layer sits the transport layer. The transport layer includes protocols like TCP and UDP. The network layer provides certain guarantees to the transport layer. One of those guarantees is end-to-end connectivity. For example, if a host has an IP address, then the network layer, or IP, provides the guarantee that a packet with that host destination IP address should reach the destination with the corresponding address with best effort. On top of the transport layer sits the application layer. The application layer includes many protocols that various Internet applications use. For example, the web uses a protocol called the Hypertext Transfer Protocol, or HTTP, and mail uses a protocol called SMTP, or Simple Mail Transfer Protocol. Transport layer protocols provide various guarantees to the application layer, including reliable transport or congestion control. Now, below the network layer, we have other protocols. The link layer provides point-to-point connectivity, or connectivity on a local area network. A common link layer protocol is Ethernet. Below that, we have the physical layer, which include protocols such as SONET for optical networks, and so forth. The physical layer is sometimes called Layer 1, the link layer is sometimes called Layer 2, and the network layer is sometimes called Layer 3. We tend to not refer to layers above the network layer by number. The most critical aspect of this design is that the network layer essentially only has one real protocol in use, and that's IP. That means that every device on the network must speak IP, but as long as the device speaks IP, it can get on the Internet. This is sometimes called IP over anything, or anything over IP. Now, the advantage to the narrow waist, as I mentioned, is that it's fairly easy to get a device on the network if it runs IP. But the drawback is that because every device is running IP, it's very difficult to make any changes at this layer. However, people are trying to do so, and later in the course, when we discuss software-defined networking, we will explore how various changes are being made to both the IP layer and other layers that surround it.